Hi, thank you so much for joining me today. First off, don't forget, if you've been liking these videos, don't forget to subscribe down below. Today, we're going to talk about the negative exponent rules. Every so often, when you're solving problems that involve exponents, you will run into some exponents that are negative. So let me show you what to do with those. Let me first start by showing you a pattern. One sec. Okay, 2 squared, or 2 times 2, is 4. Just one group of 2 is 2. Anything to the 0 power is 1. A million to the 0 power is 1. Negative 542 to the 0 power is 1. Memorize that. Okay, before I get into my negative exponents, I want you to look at the numbers 4, 2, and 1 to see if you see a pattern. So what I see is half of 4 is 2, half of 2 is 1. So if we continue that pattern, half of 1 is going to be 1 half, and then half of 1 half is going to be 1 quarter or 1 fourth. So negative exponents don't really mean negative. Negative exponents actually mean division. So what you do is when you see a negative exponent, like 2 to the negative first power, if you want to just ignore that negative sign and think that it's 2 to the first power, which is 2, and then you take that number, number 2, and you write it in the denominator, and you put a 1 in the numerator. So for this one, we would just do 2 squared, which is 4, and then we would write 4 in the denominator because negative exponents actually mean division. Let's try a couple more. Here we have 3 to the negative third power. So the first thing I want you to do is think about, well, what is 3 to the third power, okay? 3 to the third power can be written like this, or 3 to the third power is 3 times 3 times 3, which is 27. So it can also be written like this. So, like I said earlier, whenever you see a negative exponent, that actually means division. So you take that number and you write it in the denominator of a fraction. So we could write it like this, 1 over 3 cubed, or 1/27. So all three of these numbers mean the exact same thing. Your teacher would probably want you to write it one of these ways. Whenever we see negative exponents, it's kind of improper to write it like that. Let's try another one. Here we have 4 to the negative fifth power. So I want you to pretend that this isn't negative for a minute, and we're just going to rewrite 4 to the fifth power. You could also find out what 4 to the fifth power is. What is 4 times 4 times 4 times 4 times 4? Okay, and that is 1024. Okay, now like I said earlier, that negative exponent means division, so we're going to write it in the denominator. So either one of these would be the right answer. 1 over 4 to the positive fifth, or 1/1024th, like a fraction. Okay, let's do one more like that, and then I'm going to show you what to do when you see a negative exponent in a denominator. Okay, this time we have a variable instead of a number. So we're going to do the same thing. X to the negative 7th power, we are going to rewrite it with a positive exponent, but we're also going to remember that that means division. So I'm going to write it in the denominator, okay? So the best way to write this one would be 1 over x to the 7th. And that is the only way we can write it because we don't know what x is. We don't know what's being multiplied to itself 7 times. Okay, let's try a little bit more of a challenging one. Here we have 1 over, or 1 divided by, 5 to the negative third power. So I know I told you that a negative exponent means division, but when it's already being divided, it kind of undoes it. So we are actually going to write this as a positive exponent, 5 to the third power. But this time we're going to write it in the numerator, Okay, so I could write it like this, over 1, but you don't really have to do it. You can just keep it like this, 5 to the 3rd power, or 5 cubed, and 5 times 5 times 5 is 125. So either one of these would be a better way to write this, okay? A little clue is when you have a negative exponent, flip over the line, the fraction line, and change the sign. So if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. Let's do one more like this. Here we have 7 divided by 7 to the negative 4th power. Don't stress, it's not as hard as it looks. The first thing we're going to do is take this one that has the negative exponent and we're going to write it in the numerator, okay? So I'm going to rewrite it up here, 7 to the 4th power, okay? This 7 is already up there, so I'm going to keep it up there. And there's nothing left in the denominator, so I could put a 1 there, but I don't have to write anything at all, okay? The last thing I'm going to do is just combine these. I have 1 7 here, I have 4 7s there, so that would give me a total of 7 to the 5th power, or 5 7s. And that is going to be 16,807. Usually when your answer is as big of a number as this, your teacher will probably just want you to write it that way, 7 to the 5th power. Okay, now that we've practiced negative exponents in the numerator and the denominator, there is just one last thing to practice, and that is when you have negatives in both. Let me show you. Here we have 6 to the negative 4th power divided by 6 to the negative 3rd power. Now there are a couple ways to do this. If you remember the quotient property of exponents, you could do negative 4 minus negative 3, which is kind of like negative 4 plus 3, and you would end up with negative 1, and then you could write that properly. But let me show you what's really going on. This one's negative, so this is going to flip over the line and go in the numerator. This one's also negative, so that's going to flip over the line and go in the denominator. Okay, so now we have the quotient rule, which we've already covered. But basically you have 3 6s on top, 1, 2, 3, and you have 4 6s in the bottom, or in the denominator. And we are going to cancel some things out. Cancel, cancel, cancel. There is just 1 6 left in the denominator. And then there's nothing left in the numerator. When there is nothing left in the numerator, we are never going to put 0. That means when there's nothing left, our answer would be 0 all the time. So if you ever run out of things out there, we could take this whole thing and multiply it by 1, and it wouldn't change it. So technically we have a 1 left in the numerator, okay? This is probably as tough as it's going to get for now, but if you need help with more challenging problems with exponents, just comment below and I would be happy to help you. Bye!